Hello, everybody. So module 7 now of 8, we're getting very near the end. We've hit most of the major course learning objectives. Actually, I think all of them. Remember, I mentioned that we already went back and looked at it. That list is on every syllabus at Ivy Tech. It's a requirement. A lot of other schools too. If you head on to a 4-year degree afterwards, that's a requirement. That list has a different label, but the stuff you're supposed to learn in the course is going to be on there somewhere. So always check that near the end and make sure that you feel like you learned what you were supposed to. It's important going into prerequisites, or you could view it as getting your money's worth. You paid for a course, and that's the checklist of things you're supposed to learn. So you want to make sure you feel like you got your money's worth on that. One last thing is some data analytics work, which is a very big thing with Python. So we'll look at that. The assignment this week is forms and saving data in Django, but we kind of did that already. The thing we missed is the style sheet, which is not the way I would do style sheets. I'll show you how I do style sheets. Actually, I can put it in one sentence. Django has it like everything else we've seen in Django. It has a special folder, and we have to give everything special names and all of that. And I forgot that was even there until this course ran online last summer, and I saw it in the tutorial. I find it much easier just to put the style sheet somewhere else on the internet and pass in the URL to wherever it's at. Then it doesn't need any special names or anything, or have to be kept in certain ways. I don't know, something about it struck me as odd. So, or just an embedded style sheet, because usually our app doesn't have a lot of pages involved, right? There's the form and the results if we even go to another page for the results. So an embedded style sheet often works really, really well on Django as well, where we do that style tag and put all our style rules right there in the template. But there's an official spot, so we want to look at that. Data analytics assignment, we'll look at that. But first off was that thing that we ran out of time to get debugged. Heard from a couple of people we went through and found the problems with that. So I wanted to look at that. But if you remember, the point of that exercise wasn't necessarily to get it all working. It was to give you a quick idea, overview of how those go in there, and then the unprepared example to show that even after years and years and years of writing code, what normally shows in the classroom examples when I prepare and practice ahead of time is not the way writing code goes. So we didn't get that debugged. So that worked great for that second part of the example. There was some extra credit there. Let me look at what it took to fix that. Does everybody remember what was going on with that? Thinking back to last Wednesday, so 5 days ago. It's probably still open in Spider. It didn't take me long to fix it afterwards, but I wrote down all the steps that I went through to fix it. There was a little bit of a wiggle room in what I accepted and gave the extra credit points for on it. So here's the list of things I went through to fix that. So let me zoom. I should probably zoom in. So first thing I did is, it's really hard to fix the stack without being able to see what's in the stack. So I went to that generic list one that we did last Monday, I think, and I copied and pasted the display view from that, where it just prints out what's in the list, or perhaps returns them. There's a lot of print statements. Returns can be a little bit better, and that way to see what was in the list. So then when I ran it, then I come over here and I did an echo where displayed it as the stack filled up, and then again as the stack emptied, and that part was working fine. So the stack was filling up properly and emptying fine. So it wasn't a problem there. Then I noticed a little typo. One of the things we noticed quickly when we ran that was it kept saying enter boss man's hours or something. And everybody that debugged it found this pretty quick. And that was because right here, remember boss man was that fake employee at the bottom of our stack that everything else was built on top of. And so everything was actually part of that object. So when we had self.name here, it was just putting boss man's name here. It should have been the name of the thing we pulled at the top of the stack. We'll switch that to top.name, but I guess that was part of the problem because it was very noticeable it was asking for the wrong thing. Added in some echoes to make sure pay was getting called correctly. I just threw in some print statements. Print out the gross pay, the withholding, and the net. All those values came through fine. So I knew that wasn't the problem. It's still returning none. And I kept doing like we did in class and go through 2 or 3 things on the stack and then cancel it and go back, try to find the problem. Then I finally tried going all the way through the stack. I guess I kept stopping it after the top one on the stack didn't do what I was expecting, maybe the second one or something. And I noticed that the very last item on the stack, the first one in our data file, was returning correctly. So it was everything before then. That's when I realized where the problem was. We pointed out, so over here, when we pop something off the stack, well, if we're at the top of the stack, we do all that. And then return whatever that pay method would give us. But if we weren't at the top of the stack, there was no return call here. It just called the method again. So that's what was going wrong. If we're at the bottom of the stack, it goes up there. And then that last one returns the method to what called, but then the method that called it doesn't return anything back. So by the time it got all the way back, it was none. And so a couple people switched that to print, which I did accept. I was looking more for the return thing, and return is usually better than prints. In classroom examples, we're always printing stuff because we get to the end. But think about this situationally, right? If we were making the payroll calculator, we were talking about that some last week. We get our data file set up. The inputs are coming from a question, but those could probably come from another file. Oh, whoops, not that one. No. Run this one. How many hours does this guy work? So maybe 34 hours. And then we get all this information. And with the return, we're getting that back as the tuple. And the reason I was looking at that instead of just printing it out, that's all we're doing. We can print it out when we get it back. Situationally, multiple people would need that data, right? So for a payroll thing, the accounting department's going to need it in order to actually deduct that money from the bank and send out the checks. Oh yeah, and then another thing, I also added in that employee ID because we added the field in our object and then forgot to put it in the output, and that's one of the most important things. First names duplicate quickly. There's 9 people in this class, and there are multiple Kyles and multiple Gregs. So we don't have to get very many people in the same spot before names start duplicating, right? That's why we need IDs, but for some reason that got overlooked in our output, so I just added it in there. But just seeing these numbers wouldn't quite be enough. The accountants need it. The people doing the website employee dashboard would probably need it to put together the pay stub. Different offices would need that data, right? A bunch of different departments are going to need that data to be sent back to them. So instead of just printing it out, it's generally preferable to return, which is something we don't see very often in class, or yield if there's a lot of data. That way you don't have to wait for it. And then the other people can use it however they want it, because they're going to need it in different forms, right? The accounting department is going to need to take that Python tuple and probably turn that into a CSV file so they can upload it to an Excel spreadsheet. The database administrators, there's different forms, but it's in it. If we return it in the form of a Python tuple, they can write a Python script that adds it to the SQL database, company database, right? The company website people that would be controlling the employee dashboard, where we look at the paper, or we look at the paycheck stubs, because we don't see them on paper, don't get those in paper anymore. Maybe it's a Django, maybe they're doing it in Django project, so we send them a Python tuple, and they can quickly turn that tuple into a dictionary and throw it up on the Django pages. So we don't know what's going to happen with the data afterwards. And that's part of the team thing, large teams in modern software, where we know what our team's doing, but we don't know what the other teams are doing. So we just return it to them in a reasonable form. So that's what I was actually thinking when I put that together. So what was ultimately missing there was this return statement. Some people did leave that return off and switch this to a print, which is what your habit is right now from being in classrooms and doing small examples. And we're finished when we get to the example, right? We can print it out to the console and nobody's ever going to look at it again except me when I grade it. But remember where you're heading. You're heading somewhere larger, so your payroll software is going to feed into several different departments that are all using different software. So in that case, you want to return something that can be useful for them. Or like we looked at earlier, something I regularly do, I just automatically return JSON. I'll automatically return JSON, XML, and CSV every time. Doesn't take long to do that, and just add one more parameter in for which one you want. And then maybe a K for custom that would send back a Python tuple like we have here. It doesn't take long to do that. You could generalize it to a library that can reuse over and over again. And then your data is fully compatible with whatever other software people are using. Remember that word, compatibility. If your software is, the more compatible with other software yours is, the more likely it is to be used for a small task. Or for something big, lots of different reasons, but we have more than one piece of software. So you might want to make it usable with the others. Yes, Dave.
Okay, so I know a print statement only goes to the user in the console, but and the return goes to the system. Does the system get the data from the print statement too, or only if it's a return?
Only a return.
Okay, thanks.
Print statement counts as an output, which means it only goes to the human and it's done with. It's output. It's thrown out of the machine, never to be seen again. It just so happens the default on print. Let me pull it up in the help menu. The default on print is behind the Zoom thumbnails. I gotta move those. Print the values to a stream or standard out. So we haven't really seen streaming in this class, but the default, by default, it goes to the terminal. We could stream it to a printer just as well and never look at it on the screen. We could stream it across the internet and never look at it on our screen. The print statement doesn't have to be here, but it is an output. It's
but either way, both of those stream and system stand up, those are both outputs.
Yeah, that's the abbreviation for system, the system object standard output.
Okay, thanks.
SDEV. We see that everywhere. That's been around. Well, it's abbreviated. You can tell that's been around since the 80s. So we see that over and over and over again. But either one of their outputs, wherever we're going, it's no longer part of our thing. And a return goes to other software. And the print statement is other software. So it's almost always better to return it and then print it after you return it. That way you can do something else with it in software later. Because otherwise your only option is to change the print to a text file, which is more difficult than using a file handler, but print to a text file and then read it back from the text file, which is a lot of extra work. So in general, print statements are returned. But that's what was missing from that other one the other day. And we can see it goes all the way through here now. So how many hours did Alan work? 36, 23, 45. Sally was the last one at 32. So we get all of our data and we can send it somewhere else. And ideally, that wouldn't be an input from the console either. We're looking at it in the console, but we want to break away from that. We should really read that from a text file. Why don't we finish that out? Where's that feed in here? That feeds in here. How many people would we have in our workforce? 1, 2, 3, 4, 5. So we got 5 people. So I'm going to make a new file here. And I'm just going to make a CSV file. Am I in the right spot? Yeah. So this will be hours.csv. Because that's something we would get from another piece of software, right? Probably in the same order every time. So we would want to keep it straight. I'm just going to put them in a simple comma separated value. So like 32, 44, 23, 41, and 38. So there's what people worked, and that way we can read it in, but we would get that as the output from whoever did the clock in and out software. And they'd send us that output. So instead of typing those in, like we did here, where do we type that in? That adds them, that reads it in. Oh, that's over here, isn't it? So instead of typing that here, so I still didn't think about the example. I went through and found that bug. Oh yeah, there was one other bug. It crashed at the end. Because originally they said if boss is not equal none, but remember boss was a fake one that we added to build our stack on top of. So it really should have been boss.next does not equal none. I counted that as a typo error, but when we got to the bottom of the stack, it crashed out after we got all our actual data back. Well, it'd take a lot of changes. I think you all know we'd have to restructure some stuff here, but instead of that input, it'd be a lot better to read that from the hours data. We'd probably need a way to restructure it, but there's some other stuff moving on, and that was kind of the main example. Actually, I guess that feeds back into the other part that that's not going to be a quick change. That's going to take some thought. The first one just came together like this. The reading files, like, oh, reading files can be bad inside of the object. We should really just accept a parameter and read the file somewhere else. Otherwise, a lot of things could go bad. Well, actually, this is another example of it. We really shouldn't be asking for input inside our object. That just kind of came together that way. What we should do is accept a parameter and then we ask for the input somewhere else wherever we instantiate the object. I see head nods in the class. Is there some on the Zoom call as well? Does that logic make sense? Do you see how this can be problematic inside of that class? Because now we can't avoid that input. And if we were in this somewhere other than in our console, that input's a problem. So what we should really be doing is accept a parameter. I guess
Yeah, so you're saying it should be generic so that that module is always dependent on input that you're going to use from different, where you're going to pull it from this, right?
So might as well do that. And this is, yeah, back to that, making this example up along the way. That control plus, things change and stuff. It goes back and forth. We don't see that much in regular class examples. Create those ahead of time so we don't waste a bunch of time. But we're in week 7 now, so we've pretty much finished our major learning objectives. And it's mostly odds and some odds and ends that'll be useful. And I front load classes to make sure there's plenty of time to work on projects when we get to the end. Y'all have some big projects due next week, right? Probably want some time to do those. So there's lists to talk about in lecture now, and the lectures are all going to be fairly short this week and next week, just to make sure y'all have time to do that. So what we should really be doing is reading from the file. So where did that cause an error? No errors there. No errors there. Oh, I have to save it. So I saved that, and there should be an error showing up now because we changed that method entirely. Right here. We did that when we pop the stack. Oh, I got an idea. I'm going to stick with the bad form and do it right. So there's better ways to do it, but I'll read the file here. I'll just make a method to read the file. And then we'll make a list of all the hours. Bring in all the employee hours in a certain order, and just to have this finished. So we need a list. Self dot hours is going to start as a blank list. Oops. No semicolon. And I'll come down here somewhere and make a new method for this one to define the hours. So, and length. And here we can do the reading the file. So with open whatever file name we get for read mode as from file, that self.hours list, it's a CSV file, so we can use a CSV reader. Oh, guess we need to create that. Import CSV. And here can do reader is CSV.reader from file. There should only be one line, but we should still check it. So for line in reader. If the length of line is not empty, then hours are going to be that line. So with most of what you've seen so far in class, that's another one that might seem a little odd, right? Because we're used to, in previous classes, you probably heard about worrying about the input and all of that. But in the situation here, if you remember just a few minutes ago, I was talking about like, this is coming from somebody else's software. And then the output from our software is going to somebody else's software. So even though there's input and output worries, they're going to show up between programmers while debugging. So it's not like we have to worry about the user input errors so much. Because whoever developed the clock in and out software for this company is going to have that same output every time. Perhaps theirs would output a tuple directly like what we have here. And I'm just going to say it's always going to come in the same order. So then, we'll need a counter to go through it. Self dot counter. I'll set that at 0 to begin with. And then after we read that, self.counter is going to be the length of what? Of self.hours. -1, because we need indexes now. -1. That'll give us the index values for that counter as we go down. But a couple things going on here. So again, unprepared example. That's why it keeps going back and forth. So you can kind of see that it's like when you write code. It's not like the normal examples. I do practice those ahead of time. We go back and forth, but building our data structure, we have just the parts we need. There's no overhead on our list. We created our own list, which means to do that is one data field, one variable basically, to make a list. And then we built only the feature functions we need, which would be turn that into a stack, push and pop. And then the payroll that we could, which actually could go in our pop method, because our pop method just calls this one. But we don't have anything extra in our data, anything extra coming along, eating up spots in RAM. So that if we had a really big company with like 5 million employees, we're not going to burn up RAM with anything extra, any software overheads. Then here we need to pass in hours for counter. Actually, the -1 will be a problem. I just realized that here because I can't do counter -1 on the next line because we're already past, that would be past the return state. But when set counter to length, it was 1 too big. So we can just decrement it before we actually use that. And then it should be on track for our indices. Self.counter -=1. And this should be self.counter. Oh, and self.hours. Did that make all of those red dots go away? So we pretty much had the logic, missed one keyword return, and the people that turned that in for the extra credit things switch that over to print. But hopefully the idea behind making it a return makes sense, right? Because our output needs to go to other places, and we don't know what all other places they need or what format it needs to be in, but they probably don't want to read it from the console. The one actual output. So returns can be superior to print. And then we'll take away that input here, because that's one of the bad things. Having an input right in our class is just bad.
Hey, Chris, so you said that it's best to return it and then print it later. So would you go and do this and then at the end call it to print it at the bottom? Okay.
What happens with testing, right? That's what our thing does here.
Okay.
And the pop method.
All right. That makes sense.
Pop method handles all of that stuff. You notice how the logic had to go back and forth a little bit. That's probably what you all are used to a lot more than the regular class examples where I just start typing and it goes together very, very quickly. And usually have my other computer, one of my other computers sitting here with an example pulled up. But that's usually more to keep me from going down rabbit holes. Because there's a lot of subtleties we could go over. And if I don't have the example to bring me back on track, I could drift down those. So now it should be fully automatic. Let's see what happens. Nope, list index out of range. Did it run it all? Most recent call last. And top pay self.hours. So So might need to add some echoes here to see what's going on. So print self.counter. And this is how I found those problems. We have the error messages, but as you move on and progress further beyond your introductory classes, you're going to see those error messages be less and less helpful. The computer sending those error messages is not intelligent. So it's going to throw something back. And at the introduction level, especially, they are often designed so that their error messages will be helpful. So it appears that it did not do that at all. Oh, I know why. I forgot to run that. Where do we create it? Boss is the employee. We read in all of our employees. And then after we do that, then we need to read in our boss dot I forget what I called it. Get hours. Oh, and then the file name, which was hours.csv. List then not supported between string and int.
So we gotta change them both to strings here.
The integers, they are strings. So they're in a CSV file. So right now they're just text. But even though it's not coming from the input like we're used to, it's coming from a text file, so it might as well be just, it's coming from the keyboard at one point, right? I just opened this file and typed those numbers in. So they're strings, so we just need to make sure they're both, everything's an integer before we use it, which we can do here, or a float. Because if somebody works 8.5 hours and we only pay them for 8 hours, they're going to be mad. Right. Oh, there we go. So got our data, and that's more of what the situation would look like. Let me get that echo out of the way. So whenever you hit bugs, that should be your first go-to, is put in echoes. That was the first thing I did here, was print everything out. I could see the stack was filling up correctly and emptying correctly, which led back to the fact that it was printing the wrong name somewhere. Oh, in the input, it was printing the wrong name in the input. That one didn't even matter about it. Doesn't even matter anymore. Went through a few more things, and eventually I ran all the way to the end and noticed that the very last one in the stack did work. And that's when I knew that it was missing the return statement, because the last one ran fine and returned that, it returned from the last one, but none of the other ones were returning, or they only returned one step back. Oh, Zoom thumbnails, Zoom buttons are so annoying at times. Stop screen share. So we had this stack, like Sally and Chuck and Alan and whatever names were there. So we get Kyle, so we calculate his, or when we go to pop things off the stack, if we're not the top of the stack, we check again, right? The top, I'll write that like question mark, nope. So we call the next one. To the top, nope. Call the next one. Are we at the top? Nope. Call the next one. Are we at the top? Yes, we're at the top. So then this one would return. It would calculate, return the value but then none of these along the way were returning. Was the problem that was happening there? Or there was no return statement. There's always a return, but if we don't explicitly state return, the return is none. So then when we get back down here at the bottom of our stack, we were getting none every time. That's what the bug was. But again, the main point of this example was to see those bugs, because I always like to do at least one example that's not prepared in class to see how it's changing. I didn't think I was going to do that until I started talking and looked at the clock. I was like, well, let me stretch this out and kind of look at this. Also, this is where the custom data structure would come in. In classrooms, we always look at completely generic ones, like that one we looked at the one day that was like a list. We already have a list in Python. Why would we make one? And for data structures, we would work them into our custom objects, make a linked list, and then push and pop methods to turn that linked list into a stack. And then it's customized to our needs. There's no extra overhead. We have the one variable needed for that and the two methods we needed. We'll probably really get rid of display. I only use that for debugging. Those three methods, we have to read in the hours from whoever did the clock in and out software is going to send us the output from theirs. So we need to read that in, calculate all our data, and notice there's no user part in running this software now. It's just one piece along the chain. So that's what we would do. That's how our software would typically work. We're getting our input from another team on the project, right? The project manager tell us, okay, your stuff's coming into a CSV file. Your stuff needs to go out as a Python tuple. So all we know is our part. We don't know where it's coming from or where it's going. We just know what we're getting and what form we need to send it out in.
And the only reason we even got it is because they returned it to us. Okay. If I didn't get the extra credit or anything like that, but I definitely learned a very valuable lesson in that return, because I really didn't quite understand the importance of return. So
yeah, we print in classrooms, and then when the people started sending them to me and everybody was printing, it's like, oh yeah, that's what we always see in class. I should take a few minutes and try to express the importance of returns.
thank you.
And then print it later, print it from the return. That it's or yield and print it from the yield. Y'all have seen generators, but whichever way, expect to be just a link in the chain. Right? You're not the entire chain. Your software is one link in that chain. So expect, yeah. In the classrooms, we always got user input right here at the console and printed things out back to the console. But that's not a very realistic situation. So see how now there's no longer any user input? We can go change that CSV file, right? So there's those numbers. The following week, people are going to work a different number of hours. Maybe this guy worked way overtime because this person had to take several sick days or something. What is that for? 38. So here's the next week's stuff, and it runs through our software exactly the same. The only thing that changes is we get different values for what goes on their paycheck, and then we're sending it back into tuple, so that can be used in different places, right? Go to the accounting software where they actually take the money out of the bank account. Go to the people that do the website and the employee dashboard where it shows on the pay stub. If it's Django, they could take this tuple and turn that into a dictionary, throw it up on the Django template. Who else would need this data? The long-term database, company records,
HR,
yeah,
benefits.
Oh yeah, yeah, yeah. Because those deductions that we just put arbitrary percents in would be specific. They would need to know where each one goes, right? Maybe some of them go to a 401k and some of them go to an IRA. Others go to the taxes, and there's a lot of people that need this data.
So how are they calling it? Same thing, same way we're calling from our own files. How are they calling the returns?
Oh, it depends on where they're using it. That's a different situation. That would be another piece of software.
They're basically tapping into the database. So that information is only there if we get it there.
Is getting the data.
Okay.
Then what they do with the data and how they get it is on them. That's none of our business. Right? We sent them the
Give them the
data.
data, they make it information.
It depends. There's different ways to say that because it might still be data on their part. Right? Maybe they seem to take some of the meaning away from it even. Right? When HR compiles everybody's deductions and sends that off to Charles Schwab to be up into everybody's 401k, they're taking information away from what we have in our payroll section. They're sending the bulk amount over there. So if things like that would be, questions like that would be specific to the example, Dev, right? But our part is just one link in that chain. Does the general ideas there make sense? Anybody have questions? This debugging, these 4 steps I went through to find the problem, it did not take long. I was exhausted when I got home and laid down in bed and I couldn't sleep. After an hour, I got back up and it took about 20 minutes to track the problem. So it didn't take long to debug it. It was pretty much right after class. Oh yeah, and then added the employee ID field because we left that off for some reason, and that's one of the most important ones. Names are not, names aren't a good one to identify things on, unless we're standing right there looking at the person that we're using the name of. Right. There are a couple names in this class I could say, and it's still not clear who I'm talking to or about or something like that. But that finished up that example, so I will go stick that on GitHub real quick. Close this. Oh, not that button. Open up my terminal.
Kudos to everybody that got that. That's really impressive.
I need to make a folder called Git Stuff. CD and Git Stuff. So we looked at this before. We'll make our directory, and first thing we need to do is initialize it. Dot for the current folder. Now that we got that, we need to connect to our repository. So remote, add an origin, and so on the, we need to go to github.com/Francis-Chris. So I'll spell my name. Chris 5 / SDEV 220 spring 2023.git. Oh. Let's spell the word remote correctly. There we go. And then I can go git pull from that origin we just added and pull down the main branch. We get all of that. Now we have all these folders. So if I go over to File Explorer, and I could continue to do copy and paste there. I'm just going to go over here and copy and paste the folder in. So here's all the data structures, including that new project, the ones that are already on GitHub and everything. And I'll just come over here, paste this, replace the file, replace all those files in destination. That looks good. So git add dot. So check for all of the changes. No error messages, so I guess it found some stuff. Let's commit to those changes with the name unprepared class example. It's kind of the only thing we added there. Then we'll push that back to that same origin we grabbed it from. Git origin main, which is kind of bad form. They pulled down the main branch and pushed it back right back to the main branch. GitHub is a repository. The command git is more supposed to be for version control, so that stuff should have been pushed to a different thing, and we manage that. There is a class running on Git and GitHub over the summer. It's going to be a class coming to the SDEV curriculum committee. I took it up there. Was there an error message on that? I didn't notice any error messages. I forgot to look and see if there was any error messages, so I'm going to assume that's there, but I'll wait till later to delete it. Normally, I was going to delete that. So the class is coming. Those of us that were on the subcommittee planning out the cores and writing out major learning objectives and all of that, we pretty much finished that. So I want to give the class a trial run before taking it to the committee and making it officially part of the SDEV curriculum. That way there's any last minute changes we might need. Like, or after running the course, might be some things like, oh, forgot that in the initial list, or okay, this thing we put as a major course learning objectives is way overboard, way too much. So make those little adjustments before making an official course in the fall. So the test run is going to run over the summer. It's going to be SDEV 193. I put the wrong number here. I put 194, but a special topics and software development. And I just started putting the course shell together, but I did select a book. That's usually a good first thing. I went with something that's available on the O'Reilly platform. So you'll have, everybody knows we get free books on O'Reilly.com, right? If you didn't know that, go to O'Reilly.com and make sure you set up your account with your Ivy Tech user, your Ivy Tech email, and you get free access to every book on there. So here's the book, Beginning Git and GitHub. Notice they're two different things.
So you said that GitHub is the repository, and Git, did you say, was form?
No, it's something different. We'll talk about that more in the class.
Okay.
Our reading now is this. Git is more related to this. So that was what the actual command that shows up in all our terminals. Linus Torvalds invented that for version control. Then GitHub is the repository where we store all those versions and the history and all that stuff. But version control and project management are more for what the Git part. I guess GitHub is project management, useful stuff too. But it gives the project manager control over everybody's code and access and things like that. So that's where that comes in. We'll look at that stuff over the summer. If anybody's interested in taking that class, it's a special topics class, so it'll count as one of the electives. I can't remember which one, but on whatever list you're working towards, whichever degree you're working towards, one of those sections is going to say something about special topics. 180 through 193, I think, are the numbers, maybe 195 or something. That used to have to do with the regions, like Indianapolis is region 1. Sellersburg was region 13, so we do 180 plus 13 to get to our special topics. But they've added more regions, but they'd already run out of numbers, so we didn't have any more numbers, so that doesn't really line up like it used to. But I still stuck with the old 180 plus 13 gives us the Sellersburg special topics course. But that'll run in the summer. Should be an interesting class. Useful for software development. And there are GitHub certifications. I'm trying to pick which one to look at. There's a GitHub Azure with Microsoft Azure, because Microsoft has that big cloud stuff, and Microsoft owns GitHub. So if we go with the Azure certification, which it wouldn't be like the cert courses where it's included in the tuition. That'd just be something we kind of work into our quizzes and lectures and things, make sure everybody can pass that cert. It look really good on a resume. Say you're certified in that, but That's for something in the future. Registration will open the first day of the spring semester. Not really sure who made that decision. Seems like an odd day to start registration. It's going to be a lot going on that day. Seems like a good way to crash a statewide computer system. To have our busiest day, schedule our 2 busiest days for the same day. But yeah, registration will open the 20th, and it's going to be evenings over the summer, so 6 to 9. 3 credit hour and an elective. One they're kind of as elective course. Let's look at this AWS. So we go over to AWS Academy. This is the week that we had to sign up. This is what we actually needed to sign up for it. So it's the data analytics one has the lab we need. The machine learning one was just in case you're interested in that. And the data analytics, if that's where your interest lie, go ahead and work all the way through the course. We just need 1 lab out of here. 35, 40, 46, and 8 weeks, 35. So if I go in modules, go to modules. They kind of work through stuff, a little practice along the way of different things. They look at several different databases. If you're interested in data analytics, Redshift is definitely not covered in any classes here, but that is a really awesome database to work with. But we want to go down to lab 7, I think. Nope, lab 5. Oh yeah, Jupyter, SageMaker, Jupyter Notebooks, and Boca. So that was the lab that I picked. So if we go to lab 5, I could have swore it was 7. If I type lab, I'll go check the instructions afterwards. It gives step-by-step instructions, which I have to go back actually. Let me go back and switch to student view. Lab 1, 2, 3, 4, 5. I was thinking 7, so I need to make sure I didn't type that. If I type 7, it should be lab 5. The one that says Jupyter Notebooks. So if you haven't used AWS before, you go in here and click Start Lab. And it'll spin up all the start stuff, and then we'll be able to jump over there. And
So we just have to do the 1 lab, lab 5.
yes, this is the only one that's a requirement. Because before it was a Udemy thing. You might have noticed that was added into a bunch of courses over the past couple of years, but now those licenses are going away. So we have to start looking for something different. They struggled just to get a few for the course for the remnants that were around. I looked around, and this lab covered basically the same thing as that, as the Udemy lab, except that it's in situation, it's on the cloud where we would actually do this work. It's still in a Jupyter Notebook covering the same stuff. We read a CSV file and do all that. So so lab is ready. So when that's ready, we close this and then hit your AWS button, and that'll open the lab up in a new tab. And you'll just follow these. It's very step-by-step. Start lab, give a scenario, all that stuff.
So are you gonna want a screenshot of when the lab is complete? Because like in another class that I did, they wanted like screenshots of specific steps.
Oh, no, I want you to download the notebook.
Okay.
You'll do it in Jupyter Notebooks and then download that notebook and put it on GitHub like you do with your regular notebook.
Okay.
Great question though, Tiff, because I probably would have forgot that. Yes, it's in Jupyter Notebook with a bunch of other stuff that's there on AWS. Download the notebook and send it to me. And their notebook is set up kind of nice. They have it loaded in here. Well, here's all the steps for it. So we go over to AWS. Under services, I can't remember where notebooks are. On the services menu, choose Amazon SageMaker. Probably under analytics. Nope, probably got to search for it.
Just making sure I got this. So we're going to download the notebook, add it to the GitHub repository, send you the GitHub URL in Ivy Learn.
We always submit homework assignments. That's how all your homework get submitted, right? So that one should seem familiar. But then we can create a new notebook here. They've changed the button since the last time I did this, or I've been doing notebooks on Google Cloud lately, so maybe I just don't remember where any of them are. Probably under notebook. Notebook instances. That's what we want. Create a notebook instance. M1 T2 medium. So choose all the stuff. So this is the server you're gonna run your notebook on. So unlike the small notebooks you've been doing, you have a bunch of background stuff on this one. It's a big enough data set that you'll do all the steps and then go get some lunch or something while it runs through the data set. So proper data analytics stuff. But once you create that, give it permission to run all of that, create it. Once the server is going, there should be some stuff to go through. They'll have you open a file somewhere, they'll check to make sure it works. And then you open a file that oh, well, somewhere in there, they'll have a Jupyter notebook file with the instructions. It's kind of like a textbook, right? All the stuff spelled out, and then you have some cells to type into. You'll just follow through those instructions, very straightforward. Hit Start Lab. When it starts, hit the AWS button. Come over here and search for Amazon SageMaker, and just go step by step. Every step is spelled out. So this isn't like somebody else doing the tutorial. Right? This is the AWS Academy. This tutorial was written by the people who work at AWS.
If you guys can't find the AWS SageMaker, because obviously his was in recently whatever's, it's under all services and it's in the S's for no apparent reason.
Yeah, it's Amazon. They do what they want. So under all services.
All services at the top.
Oh, okay. Yeah, I just searched for it. That's why it was in recent.
Just did one of these for another class today actually, and I couldn't find it until I went all the way until I did all services. I didn't even think about using the search bar.
Oh yeah, I was going to dig through a whole bunch of these. I would have never clicked on all services. We've been here for like half an hour while I tried to click through all the different ones. Like, where is it? And then I just saw the search bar. I was like, oh yeah, those things exist. So yeah, thank you. All services, and like you said,
All the way down in the S's. I don't know why they did that.
yes.
More than likely because everything's named Amazon something, so they'd have like a whole laundry list of A's if they started with Amazon's.
Yeah, that does kind of make sense. It'd take forever to scroll past the edit, or people wouldn't know what to look for. They'd get lost in the list, our eyes would go blurry long before we found it. Should be straightforward, step-by-step instructions. That was taking the place of the Udemy tutorial, and when I found it on AWS, I kind of liked it better than that. If you did not set that up, the invitation to set up your account on there is probably buried very, very deep in your email now. So just send me a message and I will send it back out. I will resend the invitation so you don't have to dig back to emails from 2 months ago to get to the link. But if you haven't set it up yet, an email will come in, there's a link, and you just click that, and it goes and sets everything up the first time.
When's the due date on that one?
This module,
Okay.
that's your case study for this week. I think.
Speaking of case studies, have we gone over concurrence yet?
No, that was on my list to do this week. And for some reason, the thing was actually due last week. That's why I sent out that announcement. I sent out an announcement, didn't I?
Yeah, you said that. I just wanted to make sure that particular piece of homework wasn't due today.
No, it is not due today. I just didn't change the date yet. We'll probably talk about it Wednesday. Because I wanted to do both multi-threading and parallel processing and stretch things out. The funny thing, data analytics, that's what I was planning on before here. And then Wednesday, we'll look at that. So it'll push the date back. Sorry about that. I don't know why I had it in my like general outline as module 7. We looked at multi-threading. It's really, really easy. Everything's pre-built. Same thing with parallel processing, which I don't think was included and other stuff, but we'll go ahead and look at both of them. It's useful. It's really, really unusual to find a single core processor these days. I don't think they even make single core processors anymore. If they do, that's a really cheap microcontroller. It's not even the average microcontroller with single core. So we should probably look at how to do parallel processing. Where's module? There it is. I didn't realize I had scrolled. Yeah. Yeah, you gotta have a quad core at least. But what do they got? You can get chips with a lot of cores. I don't think they make a single core, so there's no point in not doing parallel processing. So in module 7, that is this tutorial, Tim. Oh, this one. So yes, it's the case study for this week. And just download the. Oh, I need to edit this. After completing the above assignment, download the files. Yeah, I guess nobody's looked at this yet because I put a note. The instructions were to remind me if I haven't changed it yet. Download the notebook.
You want the actual notebook,
Get a
no screenshot. Okay.
repository like normal submissions in prior class. I had to wait until AWS became accessible before I could check to make sure that you would be able to download that notebook. But shouldn't be any problem. Also, this week is a short microcontroller thing. This is just a lab I put together step by step. This one you'll submit screenshots, so there's not much else to do. IoT is a big deal. Read through the write-up. It's only a couple pages. If you had me in class before and saw the Python one, obviously I use the Python one here. I can send you the C++ one for Arduino. I did 2 of them and I switched back and forth between them in classes. For this one, obviously I put the Python one in here, but some of y'all may have seen the Python one before, would rather do the Arduino one. So on, you can read through that. There's a link here. That picture's out of date, I think. And it's a little simulator. Where's the link? Every link's up at the top. Oh, there it is. So you go in here and We're constantly updating things. Look like they already have a bunch of stuff pre-made. Where's the? Future projects. Oh, let's scroll farther. Oh, okay. So you need to scroll way down and go to the Raspberry Pi Pico. These are really nice chips. Microcontrollers. So the two standard ones, it's in the lab. I'll talk about this some. Are either an SBC, which is a single board computer. It's an entire computer on one chip, and this row back here, you'll see, along with the plugs we're used to, there's general purpose and out pins. So most people load Linux on there. You can load any operating system on that. You get a blank chip and just load in your operating system. You do have to strip Windows down a little bit, and you have to make some modifications to get a Mac one on there because it's not an Apple thing, but it's not bad. But it's a whole computer just on that single chip. The normal connections, HDMI, USB, all of that, and then general purpose in out pins. So we run a computer, and then we just normal operating system, usually Linux, and write some little scripts that turn the voltage on and off of these pins to turn other equipment on and off. The other device for it, I like these a little bit better, is a microcontroller. And instead of a whole system, a microcontroller runs one script. We write one program, and it just runs that one program over and over and over again. So we don't need they're more focused. We put a bunch of microcontrollers together to make a computer. So a lot of people like this because it's familiar with the computers you're familiar with. The microcontrollers run just one script. It doesn't have to be a big complicated script. So that's what's going on here. So Raspberry Pi one, they implemented a really nice chip to go on them. And the other major makers, Arduino, they took their chip and made a really nice board instead of the really cheap Raspberry Pi version. They have a really nice chip, so they've made stuck it on a really nice board, and some others did too. How about some that have full colored OLED screens on them? All sorts of little things. I really like microcontrollers, but yeah, you'll just write a little script for this. Oh, what's that in INO? Can I change that? I think I have it in the instructions. I might have clicked the wrong button. Looks like I started up the one to type in C++ here, but
That's what I was going to ask. What did you want it to be? C++ or Python?
Python is the one you should be using.
Okay, makes sense.
I should have clicked micro Python project. Oh, I did Pi Pico. So scroll way down here. Raspberry Pi Pico.
So for example, a microcontroller would be in an RC car would be one for the right tire, one for the left tire, one for the back tire, and one for the other back tire. You just write a script that says if controller says stop or turn right, then it would only issue those commands to one of the microcontrollers.
That will work. Yeah, that's a good thought for it. But basically, we have these pins, and we have these pins. We can do all what we want with them. They usually have the regular different forms of chip-to-chip communication, networking capabilities. So they'll usually have at least ICANN, which is what USB is based off of. So we can, even if there's not a USB port on your microcontroller, the ones I like are just the chip. Texas Instruments MSP 340 series. It is just a little chip with 14 pins on it. And then we have to add all of the other parts. So along with the chip, we usually have the dev board, which is something to make it big enough to work with our fingers, plug into breadboards and things like that. But yeah, whatever you would want to control. So in your RC car, you could do that. When I was a student here at Ivy Tech, we started a club doing low robotics stuff. And when I worked on an RC car, and he did it instead of 4 tires, he did front and back. He just did 2 at a time. So then he only needed 2 pins, but the same thing you were just talking about there, Kyle. There's different ways, but we could control that and then use another pin to turn lights on and off on the car. Right? You might want to put a bunch of flashy LEDs. Maybe some that look like regular headlights and others that look like fancy decorations around them, things like that. You'll just go through here and step-by-step instructions to make some, Make sure you click that link underneath the picture that says Micro Python project. That way you get Python and you'll connect things. So we, a purple button will add something like add an LED, which isn't enough to run. You need to control the voltage, or you need to control the current. So you need a resistor in there as well. Add a resistor. And then we can connect those.
What's that game we used to play back in the 80s? And it was like they gave us like a list of things to make the light bulb turn on, and we link all the little, you know what I mean? I don't know if you played it, but I mean, not a game, but I thought it was like a game, but there were just different projects you could do to make things happen. That's what that camera you just you bend back the little wire or the spring and stick the thing in there. What was that game, that thing called? It was a whole bunch of experiments.
I have no idea which game you're talking about.
I'm gonna have to find it and send it to you. But that's what this reminds me of.
We just hook things up, so then we could, so I put that on pin 8 and then back to ground, so we have an electric circuit there, and we just set that to flash or turn on when we hit a button. I think that's what the assignment is. First it's flashing, set up a loop, create a pattern, flash it in pattern, then add a button. The basic steps of it, there's not much, but all of our IoT stuff is based off that. If we can turn an LED on and off, we can turn anything on and off, right? It would be no different to turn our coffee maker on or off. It's actually no different to turn an entire power plant on and off. The microcontroller, this one in particular, Raspberry Pi's, sends out 3.3 volts, which that's not going to turn a power plant on or off, but that would turn on and off a bigger switch, which turn off a bigger switch, turn on a bigger switch, and eventually we're up in the megavolts and gigavolts coming out of the power plant, because they would use a microcontroller like this. So the button the engineer pushes only has 3 volts. That's why there's no danger of getting electrocuted when they push that button to turn on the entire power plant. But it cascades up through larger and larger switches and transformers, and eventually turns on that huge size. So if we can turn on an LED, on and off an LED, we can turn on and off anything. So that's the basic start to it. You can see there's a lot of components here. If you want to do something more interesting, some output screens, LCD screens, there's touch screens. I'm not sure how much you're going to do a touch screen there, but that does require some of the other, either I2C or some other communication protocols. A whole bunch of dot matrices. That's the ones we used to build the signs where the letters would flow past. Do better than that now. 7-segment displays are still very useful. There's just 7 LEDs and they're set up in that pattern to look like a thing. So it takes 7 pins on our controller. You can look through here and see there's some different things. Receivers and remote controls, obviously simulated here. Eventually there should be some motors. I don't see any motors. That's weird. Oh yeah, there's a motor. So different types of motors to get movement. So for a remote control car, you would probably want a DC motor. Buzzer, servo. So you would probably use it. That's only stepper motors. I don't know why they don't have a DC motor. DC motors are the ones that are just like the opposite of a generator. They're the same thing, but if you apply motion, you get electricity. If you apply electricity, you get motion. So that's the one that just spins and spins and spins. That's what you want on an RC car. Stepper motors, you control how far it turns. Like it'll turn a third of the way around or quarter of the way around, and you get that certain thing. Servos, you turn to an angle. So usually they have like a sweep angle, so you'll sweep out like 45 degrees, then come back. So that'd be like movement on an arm. Different types of motors bring in movement, lots and lots of pieces. For the assignment this week, you just need to follow the steps, and you'll make an LED flash on and off. And so you can see even all of the pins have multiple labels. So we can do multiple things with each one of our pins too. The ground pins are the only ones that don't have a single label, because obviously that's where we bring things. That's where our circuit comes back to, bring things back to ground. But everything else, you see, there's a lot of different labels on what that can do. UART, I2C, SP, SP, and general purpose in out. Lots of different communication channels on each pin. We have lots of control. A little bit beyond what's required, but yeah, you'll just turn an LED on and off. But that's the basic part. So if we can turn an LED on and off, we can turn anything on and off. And y'all are probably wondering about now. Go ahead and stop and take a break 10 minutes ago, huh? Because this is week 7. Y'all have big projects coming up. I front load classes to make sure that there is plenty of time to work on projects when we get near the end. So we still need to talk about styles, where to put the style sheet in the Django stuff, and then the multi-threading things, because that homework was passed due. It won't be due until we talk about it, which will be Wednesday. And then the style sheet is just showing you which name of the folder it is in Django. So that will go very, very quickly on Wednesday. But this time of the semester, the project needs to be the main thing, right? There's a lot of points there. We want to make sure there's plenty of time to work on a project when I'm around, ready to answer questions if anybody has any. So that's why I stretched that out a little bit longer, and then we'll look at some code then. Does anybody have any questions before we wrap up then? Okay, so a short lecture tonight. That leaves us over 2 hours of just time to work on stuff. And I'm going to be sitting in either in the classroom here or in my office, probably in my office, so I don't distract the people in the classroom. But I'll be sitting in my office just waiting for questions to come my way until 9:50. So if you have any, let me know. Otherwise, I think that was more than 5 seconds to ask if anybody had any questions. So I will see y'all on Wednesday. We'll look at multi-threading, parallel processing, and then where do we put our style sheet on Django? It's a folder called
Concurrency.
hard, but I will see you all on Wednesday.
Thanks, Chris.